Everybody, it's Mick here. I'm on a train from Sydney to the Central Coast to see my family. Thought I'd share some quick thoughts around some big um, laws and paradoxes that exist in electricity, in AI, and computing, which are really going to affect us. And because of their complex relationship, I think the end result is actually going to be very interesting, but no clear outcome, which again is easy to try to poke holes in, but actually it's just the reality. And the first one is Wright's law. So Wright's law talks about how as the product scales, it significantly reduces its cost. So it's a pretty good article here on Medium by Tom Connor, talking about how multiple products have shown over time as we significantly reduce their cost by scaling up and scaling up. They get cheaper and cheaper and cheaper. And here's the key thing: so as you deploy more, the prices fall. It gets more competitive in new markets, and demand increases. So then you deploy more. So there's a big virtuous cycle around it. And if you look at energy, we actually see that for coal, it's been pretty flat over a long period of time, but obviously it's had hundreds of years to get to sort of full maturity. Nuclear is actually still going up in cost because it's not really being deployed at massive scale at the moment. Whereas we take this line here, solar energy in the last 10 years has gone down dramatically. And this is obviously just over the last 10 years. This is not at that levelized cost sorry, this is expressed in the levelized cost of energy, but we're not talking about the hundreds of years of some of these other products. But you can see that as solar has massively scaled out, it's dropped in price enormously. So 89% drop over those 10 years. Hopefully, really taking down to 10. And the same thing for so wind has gone down 70% from 135 down to $41. So also really good to note that the actual lowest cost of levelized cost of energy is wind at $41 and solar at $40. The next law we want to talk about actually is Moore's law, and this really applies to AI and also broader computing and also quantum computing. But it basically says that every 2 years, the number of transistors you can have on a microchip doubles. Really, the best way to think about it is how computing doubles every 2 years, and that's been really consistent from 1970 through to 2020. And even though obviously we don't even think about it anymore, when I was growing up, we used to have an IBM 286, and then there was a 386, and there was a 486, and your speed might go from 10 megahertz to 20 megahertz to 40 megahertz, and now we don't even talk about that unless you're playing like hardcore gaming. But we know that the chips are improving, and obviously this really impacts in terms of AI, which require different kinds of computing. And quantum is the same, but they're very early on in their journey. And the last thing to bring on here is Jevons Paradox. This is Jevons here. And Jevons Paradox basically says that as something increases in efficiency, people use it more. So there's this big thing around electricity, which is, hey, if we can actually use renewable energy to get the price down, that'll be great for improving the environment because actually we'll be consuming less electricity. And what actually typically happens is as it gets cheaper and cheaper, we use it for more and more things. So I think this is especially true since a lot of the world doesn't have access to regular energy. So this example here on Stanford University is based on a hybrid car, and it's saying basically hybrid car can actually get cheaper per mile per kilometer, and therefore I'm going to actually drive it more because it's much cheaper. So the interplay between these three laws, so Wright's law, Moore's law, and the Jevons paradox, for both climate and AI is really interesting and again really complicated. No simple answer. There's multiple bodies at play and not so many things in terms of policy, technologies, implementation, and scale, investment. Everything goes into this. What we do know though is absolutely the more renewable energy we use, the faster we transition to that. Even if it's cheaper, that's great. Use it more and more. Then if you're using a hybrid car because it's cheaper, then that's great. Like that's a really good opportunity. And as that increases the scale, and then the price increases. But we do know again with Jevons paradox, I think particularly with AI, thinking that we're absolutely not going to stop using AI. So we almost want to embrace it and get it to scale and efficiency as fast as we can, so then we can use it to actually solve the many problems that we do to something different. Anyway, interesting thoughts there about Wright's law, Moore's law, and Jevons paradox. And I hope you enjoyed today's chat. Thank you.